Welcome to my channel, Chemistry Class. Good morning, everyone. Welcome back to Chemistry Class. My dear student, I hope you are all doing well. My dear student, today we are going to study a fundamental concept that forms the backbones of moles calculation in chemistry, which is Avogadro's number. My dear student, by the end of this lectures, you will understand what is Avogadro numbers, why do we need it, and how to apply it in chemical calculations. So let's start with the definitions. Avogadro's number, my dear student, Avogadro's number is the number of particles, atoms, molecules, or ions present in 1 moles of any substance. Avogadro's number is the number of particles, atoms, molecules, or ions present in 1 moles of any substance. This number is 6.022 multiplied by 10 raised to the power 23. But dear student, this is a very large number. Yes, it is a huge number. Just like a dozen mean 12, a mole means 6.022 multiplied by 10 raised to the power 23 particles. My dear student, this number is named after the Italian scientist Amido Avogadro, who first proposed the idea that equals volume of gases contain equal number of molecules at same temperatures and pressure. Now, understanding the size of the number, let's understand how big this number really is. Imagine 1 mole of marbles 6.022 multiplied by 10 raised to the power 23 marbles. If you could count 1 million per second, it would take millions of years to count all of them. If you spread 1 mole of sand grains over the earth, you could cover the entire planet several meters deep. That's the scale scientists deal with when they study atoms and molecules. My dear student, that's the scale scientist deals with when they study atoms and molecules. Now, why is Avogadro's number important? Why is Avogadro's number important? Because atoms and molecules are too small to count. Individually, we use moles and Avogadro's number to relate mass to number of particles. So in practice, 1 moles of hydrogen atoms is equal to 6.022 multiplied by 10 raised to the power 23 atoms of hydrogen. 1 moles of oxygen molecules is equal to 6.022 multiplied by 10 raised to the power 23 molecules of oxygen. Similarly, 1 mole of sodium ion is equal to 6.022 multiplied by 10 raised to the power 23 sodium ions. Now, Avogadro's number in calculations. My dear student, let's look at some simple formulas. The first one is number of particle is equal to moles multiplied by Avogadro's number. Examples: how many atoms are there in 2 moles of carbon? Simply 2 multiplied by 6.022 multiplied by 10 raised to the power 23, which is equal to 1.2. 0.04 multiplied by 10 raised to the power 24 atoms. And the second one is moles is equal to number of particles divided by Avogadro's number. Examples: if you have 3.011 multiplied by 10 raised to the power 23 molecules of water, how many moles is that? How many moles is that? So moles is equal to 3.011 multiplied by 10 raised to the power 23 divided by 6.022 multiplied by 10 raised to the power 23, which is equal to 0.5 moles. My dear student, that's all about the Avogadro's number. I hope you all understand. My dear student, that's all for today. So, if this lecture helped you, then don't forget to like the video and subscribe to the channel and press the bell icons, and also comment your questions or any confusions. So take care and see you in the next class. Thank you for listening.